Hi, this is Marina from Greenpeace Global Mapping Hub, and now we will talk about remote sensing. Nowadays, there are lots of satellites that orbit Earth and gather data about our planet. They often have a number of sensors or cameras. For example, NASA's Terra satellite has MODIS, Aster, and other sensors that gather different types of data. A part of this data is open and a part of it is free. We can use it to find out about events if their location is hard or impossible to access quickly, like for example wildfires in Greenland. Track changes by comparing different images with decades of archived data, like for example drying out of lakes. Make spatial analysis, like for example, classifying imagery for area calculation. There are two types of remote sensing, active and passive. Active is basically a radar. It emits light or radio waves and detects the reflected radiation. Passive sensing is like a photo camera or our own eyes. It detects radiation that is emitted by the sun and reflected from the Earth's surface. Why is it important for us? These two types of remote sensing allow us to get different types of data. Active sensing allows us to get topography of the Earth's surface. It is able to make measurements at night and see through the clouds. We can use this data to monitor atmospheric composition, sea ice, detect oil spills or ships. Passive sensing, just like a camera, provides us with imagery of the Earth's surface. The majority of satellites use passive sensing, so we have loads of data collected over 50 years. We can use it to show the consequences of natural or technogenic disasters by comparing images made before and after an event, or track mining, deforestation, infrastructure development over decades. There are two major ways how satellites orbit the Earth: sun-synchronous and geostationary. Sun-synchronous orbit is where a satellite passes over the same part of the Earth at the same time of the day. Those are usually low orbits. Geostationary orbit is where a satellite is above the same part of the Earth at all times. Those are usually high orbits. Why is it important for us? When we aim to make environmental observations, we want to get high-quality data as frequent as possible. This is called spatial and temporal resolution. Sun-synchronous, low-orbit satellites allow us to get high-resolution imagery, but as they can only capture a narrow swath of the surface, it can take days between imaging the same area. Geostationary, high-orbit satellites allow us to get lower-resolution imagery over a larger area, but as frequent as every several minutes. It is also important how sensitive a sensor is to be able to detect small differences in reflected or emitted energy. This is called radiometric resolution. A sensor with a finer radiometric resolution than another records more significant intensity levels so that we get more information from an image. But that's not it. Here is where the magic happens, as remote sensing also allows us to see what is hidden from a naked eye. Satellite sensors often detect a wide spectrum of waves, including not just visible light, but also infrared. This allows to highlight different types of objects based on their spectral reflectance by combining different bands, for example, vegetation, water, or burnt areas. This is called spectral resolution. Some of the satellite data sources are Sentinel Hub, Landviewer, and Worldview by NASA. You can try them out yourselves. The links are in the description. As all data sources have their limits, every time you face a task, you must choose what is more important for you: frequent update, detailed imagery, or spectral resolution. Based on your answers, you can choose between available data sources. So, why remote sensing is especially useful for environmental protection? It is a source of loads of free data. We can bear witness remotely where we can't get quick enough. We can make analysis and predictions, calculate area, find out about illegal activity, and our results are based on independent, open data and not on official statistics that can be falsified. This allows us to know the truth and be credible. There are also limitations to remote sensing. If it is cloudy, we can't see the picture with passive sensor. Usually, the higher quality you have, the less frequently the image is updated, and vice versa. And best data is not free, unfortunately. If you are as fascinated as I am by the opportunities of remote sensing, watch this video that shares tips on how to interpret what you can see on satellite imagery. Here we talk simply about mapping.